So our last video of the chapter, we're going to be looking at what can you do more with just the scientific numbers. And so what we're looking at is that we can multiply and we can divide them. Now, the first thing you need to remember is this word commutative. I've said it a few times throughout the year, and I'm guessing each time you've ignored the word itself and just kind of went on with what I was saying. But the idea of commutative is that you can multiply in any order. So if you remember 2 times 3, well, I can say that's the same thing as 3 times 2. It's really cool. You can do that with multiplication. Well, we're going to use that to our advantage here as we are multiplying as we're multiplying scientific numbers. So let's look at this. So I have 1.4 times 10 to the 4th. That's my first scientific number. And I'm going to multiply that times 7.6 times 10 to the 3rd power. Okay, so let's just understand our notation here. If we look at it, we have a multiplication within our scientific number, right? We have 1.4 times 10 to the 4th. That is really just multiplication. So if we ignore the structure of scientific notation, we have this number times this number. And then same thing over here, we've got this number times this number. And then what do these bubbles mean? When we write these bubbles, what we're saying is we're taking this times this. So really, we just have a whole lot of multiplication. Let's check it out. If I wrote it without the x's and without the bubbles, if I just wrote it out as multiplication, I've got 1.4 times 10 to the 4th times 7.6 times 10 to the 3rd. And because multiplication is commutative, I can reorder things. So let's just make a switch with those two. So now I've got 1.4 times 7.6 times 10 to the 4th times 10 to the 3rd. And I can take, and now I can just multiply the numbers that are like each other. For example, the 1.4 times 7.6. I'm going to go ahead and use a calculator. I'm not expecting you to do this by hand. So I multiply those and I get 10.64 times, and I'm going to go back to using my x because now it's going to be in scientific notation. And hey, I've got the same base being multiplied. Hey, guess what chapter we're in? The exponent chapter, which means we use our exponent rules. So I've got the same base, so I'll keep my 10, and then with my exponents I add them together, so I get 10 to the 7th. Now wouldn't it be great if we're done? Sometimes you're done at this point and sometimes you're not. So how can you tell? Well, look at our problem. Are we in scientific notation here? If we just go real quick, we see a times 10 to a power, and we're going to like, yeah, we're in scientific notation. However, look at this guy. Remember how many digits we can have in front of the decimal? We can only have one number in front of the decimal. So we have to rewrite this guy. We can't have that. We need to have 1.064 times 10 to the, oh no, it can't be 7 anymore because I have moved a decimal, haven't I? I have moved a decimal. And so now it can't be 7. So it's either going to go up to 8 or it's going to go down to 6, right? Because I moved the decimal one place. So which one is it going to be? Up to 8 or down to 6? You know, this is always a place where people struggle. What do I do? How do I know which way to go? So here's what I suggest. Look at your original problem here. And look at what the rule tells you to do. It tells you to go 7 to the right. So you're like, woohoo, 7 to the right, right? But I just moved the decimal one more place. You still have to get to here, right? You still need to get to here. You still need to go these 7, but you need to go one more to get there. So now I know I need to go to 8. But that's not always going to be the way. So you have to, I just highly recommend just writing out, do your woohoos here, do your loop-dees and see what do you need to move to be able to get it so that it's still going to give you the right number after you do your exponent. All right, so there's my answer. All right, so now let's go ahead and we're going to go to another example. So my next example is I'm going to take 1.2 times 10 to the negative 1, and this time I'm going to divide by 4.8 times 10 to the negative 4. And here's the cool thing. Because we're dividing and multiplying and all that good stuff, we can look at these separate. So I can go ahead and take these ones and divide them. So I can take 1.2 divided by 4.8, and I get 0.25. times, and then I can go here and divide these ones. Again, we're in the exponent chapter, so I'm going to take 10 to the -1 minus -4, and be careful about this. Look at that, I've got two negatives, and the reason I have two negatives is because I am minusing a negative exponent, which is why it's so important to write your exponents here. So now what I have is 0.25 times 10 to the, let's see here, I've got two negatives, change it to a plus. -1 plus 4 is a +3. All right, now, once again, you guys, we are not in scientific notation. At first it looks like it, but I need one number in front of the decimal. So I've got to rewrite this sucker here, 2.5 times 10 to the, I have to worry about my exponent now. Now, according to this, I have to move it 3 to the right in order to get it to work. But I've moved my decimal to here. So now I've skipped a whole place. I still have to get it to the same spot, but now I only have to move it 2 places. So this is going to be my answer. Now this takes a lot of thinking, and so don't expect to do this without thinking. You need to give it some good time and thought before you do it. I have one more example of something you can do with scientific notation that's kind of cool. And that is, what if you have 1.5 times 10 to the -4, and then you raise that to the 3rd power. So once again, we're using our exponent rules. And remember, with this exponent rule, if I have a multiplication, I can go ahead and apply this exponent to both of them. So I can say 1.5, and the 3 goes to that one, so 1.5 to the 3rd, times 10 to the -4, and then the 3 goes to that one, so I put it there. And I take 1.5 on my calculator, and I raise that to the 3rd power, so I get 3.375 times, and then you take your exponents. Remember what it says to do? Take your exponents and multiply them when you raise it to another exponent, so I get -12. And good news, guys, this is in scientific notation. It's times 10 to a power, and we've only got one number in front of the decimal. So we are done with this guy. We can just go ahead and circle it and be done, but always make sure that you check. So you can multiply, divide, and do exponents on scientific notation. You just have to be careful with your answers.